This is a video just going through example 5 on page 105 for one-tailed tests. In a lesson before half term we went through how to do a hypothesis test. So now it's like applied to a real life situation. So it says the standard treatment for a particular disease has a 2/5 probability of success. Okay, of success. And it also says that a certain doctor has undertaken research in this area and has produced a new drug which has been successful in 11 out of 20 patients. So 11 out of 20. The doctor claims that the new drug represents an improvement. So he says this 11 out of 20 is an improvement. That's his claim. What we're going to do is do a hypothesis test to see if his claim is right. And it says test at 5% significance. So before we actually do the question, just going to work out what does this mean. Okay, so this is what the probability of the drug being successful before, about 40%. And he's saying that 11 out of 20 patients is an improvement. So what we want to do is to work out the probability. Well, if we did a binomial distribution with 20 as the number of trials and 11 or more 11 or more successes, yeah, because this is an improvement. So with a probability of 2/5, a binomial distribution with a sample of 20, we're working out how likely is 11 or more successes. What's the probability of 11 or more successes? And we compare that with 5%. So is there a 10% chance of this happening with this probability? Is there 15% chance? Is there a 2% chance of this happening? That's basically what we're working out. What's the probability of 11 or more patients being successful with this treatment? That's basically all it is working out what that probability is. So whenever we do a hypothesis test, the first thing is we write down what the null hypothesis is, and it's always what the probability was before. Okay, what it is if there actually isn't any improvement, and that's 2/5. Now, because this doctor's claimed that there's an improvement means, well, then there should be more than 2/5 of the patients being, improved with this, whatever it is, this new drug. So it's greater than 2/5. So if he's correct, then more than 2/5 of the patients will be will sort of it'll be successful with. And we want to work out, well, is this an improvement? What's the probability of this? 11 out of 20 for this. Okay, so what have we got? We've got a binomial distribution, and these questions always like binomial distribution. The number of trials is 20 because we're picking out 20. And the probability, that's the other thing we need with a binomial distribution, is 2/5. Okay, and what we're trying to find out, what's the probability that 11 or more, because it's what we call an upper tail test, because that's greater than, whenever that's greater than, it's upper tail test. What's that probability? Now we know we can't work that out directly because the tables and our calculator don't do greater than. So you should remember that if you're going to do a number line, so 0 to, well, we got up to 20 successes, and we want to find 11 or more. Okay, so the way that we're going to do that is we're going to find the successes up to 10 and then take this away from 1. That'll give us 11 or more. So 1 minus the probability that x is less than or equal to 10. So it's going to be 1 minus, so we get the calculator, remember menu 7 and we want binomial CD, so it's, you press down, and then we want binomial CD, which is 1. We want it as a variable, number 2, and X in this case is 10, not 110, it's 10. N is 20. And the probability is 2/5, so 2 divided by 0.4. Okay, now what that gives me is this number. Let me just check that I've typed it in correctly. Yeah, so 10, 20, 2/5. Yeah, so 0.8724 ... So the easy way to do that is menu number 1 and 1 minus the answer, and we want 4 decimal places, so 0.1275. okay, which if you wanted to you could write as a percentage, 12.75%. So what have we found out? We found out that if the probability of this drug being successful is 2/5, and we pick 20 patients, and it works out of 11 out of 20 of those patients, then the probability of that, of 11 out of 20 patients, it being successful for probability 2/5, there's actually a 12.75% chance of this happening. 11 out of 20, where I'll write that, 11 out of 20 here at this probability. Yeah, so if we take it back to normal binomial, if you've got 11 items and you pick out 20 and there's a probability of 2/5 of success, then the likelihood of you picking getting success for 11 or more of those items is going to be 12.5%. Now, as far as a hypothesis test is concerned, if the probability of that thing happening is greater than the significance level, and this is greater than the significance level, the term that I use is we consider this as something that's likely to happen. If it was less than 5%, we'd say that this is unlikely to happen. Now, what do I mean by likely and unlikely? So this is likely to happen with this probability, because that's what we've just used. If this was less than 5%, we'd say that this is unlikely to happen with this probability, so it is likely to happen with this probability. Now, because this is likely to happen with this probability that we've tested, because we used it here, and we always test the null hypothesis, we find out how likely is this, and this is likely because it's more than 5%, then what we say is this, that we accept H0, okay, so because we're saying that this is likely with this probability, accept H0, so that's the first thing, and then you always need to write what I call a contextual comment, which is, okay, well, how does this link to the question? So this was about this drug improving the outcomes of patients, and he claims that, the doctor claims that new drug represents an improvement. So we must write something like this: there is insufficient evidence to show that the new drug is any improvement on the old one. Yeah, so always some sort of comment that is linked to what this question is about. Okay, so any question like this, you're looking out for 3 key bits of information, or 4 key bits of information. Number 1, what was the probability before? What was the probability before this thing happened? That goes here. Number 2, how many items in our trial. In this case there are 20. Okay, so that went there. Number 3, there's always going to be something like 11 out of that number or 10 out of that number. There's going to be a number out of that, and that's the number that goes here. And then the other thing we're looking for is something like, is there an improvement, was there a decrease, is there a change? And that's going to tell us about what sign goes here. Now basically, if you've got this bit of information, then this is exactly the same as what we did previously with binomial. So what you're just trying to work out is, what numbers do I need here, here, what number goes here, and what symbol goes here. We work out that probability, and then we compare that probability answer to the significance level. And what we said before is that once you've worked out your probability, your percentage for example, if it's greater than the significance level, then I say that it's likely, so we accept H0, then we write some sort of comment. If that percentage or decimal that we worked out is less than the significance level, then I say it's unlikely, then we reject H0. And again, some sort of statement like there's insufficient evidence or there's sufficient evidence to suggest whatever the question's about. Okay.